Much like people, it is a fact of life that some matrices are nicer than others. In this lecture, I want to go over row echelon forms. And specifically, we'll talk about two what's called row echelon forms. One will be much more prominent in this course than the other. So let's jump right into it. So the context here is lots of matrices are very difficult to work with, but some matrices are easier to work with. So let's say that we're working with an m by n matrix, and let's say that matrix is called R. So in this example, our matrix looks like it's 4 by 5. We say that our matrix is in reduced row echelon form if 4 things are satisfied. So we need 4 rules to pass in order to call our matrix reduced row echelon form. So what's the first rule? The first rule says that if there are any rows that are full of all zeros, those rows need to be at the bottom. And in our example here, we see that this rule passes. The only row in this matrix that's full of all zeros is the last row, which of course is at the bottom. So rule number 1 checks out for this matrix. So far, so good. Rule number 2. All of the other rows, so these are the rows where not every single entry is equal to 0, although we could have some entries equal to 0. These other rows have to have first non-zero entry equal to 1. And these are very, very important entries inside of a reduced row echelon form matrix. And they're so important that they have a special name. These are called pivots. So remember, the last row in our matrix is all zeros. So forget about that row. It's at the bottom. We're not worried about it. And if we go to all the other rows, here's the first row. The first non-zero entry is equal to 1. That is our first pivot. If we look at the second row, the first 2 entries are equal to 0. That's fine. The next entry is the first non-zero entry. This entry is equal to 1. That's our second pivot. Our third row is the last row that's not all zeros. Its first 3 entries are equal to 0. Again, totally fine. But the first non-zero entry is right here in the 3, 4 position. That position is equal to 1. That's our third pivot. So the second rule for reduced row echelon form says the first non-zero entry of a row that's not all zeros has to equal 1, and those positions are called pivots. What's the third rule? The third rule says that every pivot must occur to the right of all of the pivots above it. So if we're looking at any pivot and we look above for other pivots, the pivot we're looking at needs to be to the right of all of those. So if we look at our example here, our first pivot in the 1, 1 position, there's nothing above it, so there's nothing to worry about. In the second row, we're looking at the 2, 3 position. There's 1 pivot above this second pivot, but the second pivot is indeed to the right. So that's okay. Then when we go to our third pivot is here in the 3, 4 position. There are 2 pivots above this third pivot, but this third pivot is to the right of both of them. So for pivots, we go right and down. So the third rule passes here. So we are on track to be reduced row echelon form. I promise there are 4 rules though. What's the 4th rule? The 4th rule says that all non-pivot entries in a column containing a pivot must be equal to 0. So if we look at our example here, we have 3 pivots, which means we have 3 pivot columns. And the rule says that every column that has a pivot can have the pivot, but then everything else is equal to 0. So if we look at our first column here, we have our pivot and everything else in the column is equal to 0. That's cool. Then in our next column with a pivot, that's the third column of this matrix, we have our pivot position and everything else is equal to 0. Great. And then for our third pivot in the 4th column, we have our pivot position and everything else is equal to 0. The 4th rule passes here, so we can call this matrix reduced row echelon form. So the way we write this is we called this matrix R. So what we would write here to efficiently communicate that this matrix is in reduced row echelon form is we would write R equals RREF of R. RREF is an abbreviation of reduced row echelon form. Great. So these matrices play an enormously important role for us. So it's important that we understand how to identify them. It's key here that there are 4 rules, and the matrix needs to pass all 4 of those rules, or follow all 4 of those rules if we're going to call it reduced row echelon form. So let's look at a few examples to test our understanding here. So here we have a new matrix, also called R. This one's a little bit bigger, I think. This one looks like it's a 5 by 7 matrix. So this is a larger matrix. So what are the rules? The first rule says that if there are rows of zeros, they can be there, but they have to be at the bottom. And here we do actually have rows of zeros. The last 2 rows of this matrix are all zeros, but that's fine because they're at the bottom of the matrix. So the first rule passes. What about the second rule? The second rule says that all of the other rows, so the rows that aren't all zeros, have to have first non-zero entry equal to 1. So if we look at the first row here, the first row starts with a 1. That's great. That's our first pivot. In the second row, we start with 2 zeros. That's fine. But the first non-zero entry is in this 2-3 position. That's equal to 1. That's our second pivot. Now when we look at our third row, this is the only remaining row that's not all zeros. If the first 1, 2, 3, 4 positions are all 0, totally fine. The next position is the first non-zero entry in the third row. It is equal to 1. That's our third pivot. The second rule passes, and here we have 3 pivots. The third rule says that the pivots need to move right and down. So every pivot needs to be to the right of all pivots above it. So to get from the first to the second, we travel right and down. Great. To get from the second to the third, we travel right and down. Great. The third rule passes. The fourth rule says each pivot needs to be the only non-zero entry in its column. So if we look at the first pivot, it is the only non-zero entry in its column. We have the pivot and everything else is equal to 0. Good. If we look at the second pivot, it is the only non-zero entry in its column. So we have our pivot here in the third column and everything else is equal to 0. Great. And then finally, our last pivot is in the 5th column here. 1, 2, 3, 4, 5. In the 5th column, the pivot's there. Everything else is equal to 0. The rule passes. There's no other pivots to verify here. So great. This is another example of a matrix that's in reduced row echelon form. So here, it's appropriate to write R equals RREFR. This matrix is in reduced row echelon form. One thing that's important to point out here is we require pivots to equal 1, but not every 1 in the matrix is a pivot. For example, in this here we have a 1 in the first row in the 1, 2, 3, 4, 5, 6 position. So this is in the 1, 6 position. This is equal to 1, but it is not a pivot. A pivot is the first non-zero entry of a row that's not all zeros. And when we say something is in reduced row echelon form, the pivots have to equal 1. Let's look at our next example. So here we have a smaller matrix. This one looks like it's, 3 by 5. What are the rules? The first rule says that if there is a row of zeros, it needs to be at the bottom. In this example, there are no rows that are all zeros, so we don't have to worry about the first rule. First rule passes. The second rule says that all of the other rows, so in this case, all of the rows, have to have a first non-zero entry equal to 1. Well, in the first row, we start with a 1. That's our first pivot. In the second row, we start with a 0, which is fine. And the first non-zero entry is in the second position, so the 2, 2 position here. That's equal to 1, so we're good. And then finally, in the third row, we start with 3 zeros, totally fine. And then the first non-zero entry is in the 4th column. That's equal to 1. We have our pivots. So the pivot axiom passes. Our other rule says that pivots must occur from right and down. So every pivot must be to the right of every pivot above it. To get from the first to the second pivot, we travel to the right and down. Great. To get from the second to the third pivot, we travel right and down. Great. So we have pivots. The pivots go, every pivot is to the right of every pivot above it. That's great. So we have one more rule to check, And that rule says that pivots can be the only non-zero entry in their respective columns. If we look at the first pivot in this matrix, we have the pivot and then 2 zeros. Great. If we look at the second pivot, we have the pivot and then 2 zeros. Great. And then we're just about to get there. However, if we look at the third pivot in this matrix, we have the pivot position, but right above it is a 2. 2 is not equal to 0, so that axiom fails. Our rule for reduced row echelon form, we almost got there, but the rule that says that pivots can be the only non-zero entry in their respective columns fails. So even though we're real close, this matrix is not in reduced row echelon form. So here we write R not equal to RREFR. We almost got there, but not quite. So again, the rules for reduced row echelon form are super strict. We have to pass all 4 of the rules in order to be in reduced row echelon form. We got close, but we didn't make it here. So cross it out. Here's another example. So this one's pretty big as well. This is like 6 by 7. Let's run through the axioms. So as you start to do a lot of these, you get more comfortable with the axioms. Here we have 2 rows of zeros. They're at the bottom. Everything's good so far. If we look at all of the other rows, the very first entries that's not a 0 is a 1. So we have our first pivot in the 1, 1 position, our second position in the 2, 5 position. Our third pivot is in the 3, 3 position, and our fourth pivot is in the 1, 2, 3, 4, 1, 2, 3, 4, 5, the 4, 6 position. So the first non-zero entry of every row that's not all zeros is equal to 1. So we have pivots. And if we look at all these pivot columns, the pivots are the only non-zero entries in their respective columns. So we're doing pretty good on the axioms, but you may have already seen it by now. As you can tell, not every pivot is to the right of all of the pivots above it. To get from the second pivot to the third pivot, we travel to the left and down. So even though we're real close with this one as well, this matrix is not in reduced row echelon form. We passed most of the axioms, we passed most of the rules, but we didn't pass all of them, so this is not in reduced row echelon form. Real close, but not quite there. So cross it out.